Hello, welcome everybody. My name is Gergő Bóta. I'm working in Digital Automation Cloud R&D. This session is recorded in 2021 November, and in today's session I'm going to talk about the troubleshooting capabilities of the NDOC systems, how through the NDOC Manager customers can troubleshoot the main parts of the system, including the edge, the SIM, and then the access points, and how on the high level the NDOC software management process is being organized and being carried out, how the data center, how the edge, and how the radio software upgrades are working. These are the two main topics of today. And let's start with the troubleshooting topic. You might already be familiar with the NDOC UI, where you can see the one main print screen on this slide. So this is the main interface towards the NDOC networks. This is the main interface to provide information and also to troubleshoot the networks. The main parts of the system are the edge cloud, so the edge hardware, the access points, the SIMs, and then optionally the applications. And this portal, the manager provides status information, management, and troubleshooting capabilities for these main parts of the system. Something we are going to go through in the next couple of slides. And in the next slides, I'm going to go through on this discovery view, under which basically you have the submenus where you can access the main parts of the NDOC systems. Let's start with the edge computer, which is basically the computing platform, the computing hardware, HP or the OpenEdge hardware. And under this view, you can see all edge hardwares belonging to this given account. You can see that to which network that given hardware belongs to. There can be like a customer defined name that the customer can assign to a given hardware to a given network. You can also see, I would say, the main property, the main thing related to an edge hardware, whether it's connected or not to the data center, which is required for all management activities. And once you click on a specific edge cloud, once you click on a specific edge hardware, then you can also see, for example, the hardware ID of it. And the basic management capabilities and troubleshooting capabilities that the customer UI allows related to the edge clouds are rebooting and shutting down the hardware. So the rebooting, obviously, it will reboot remotely the hardware itself, which obviously causes private LTE downtime since all the services goes down, and then shutting it down remotely in case, for example, it's not being used, and put it offline for as long as it's needed. This rebooting and shutting down the edge, it can be also made available under this network view, something that now you can see on this video. So on this network view, you have all the networks, and once you click on a specific networks, then it gives you also the view of the edge cloud, which belongs to that given network. And by clicking on that three dots, you are also able to execute the same shutdown and reboot operations. The next thing to talk about is the network reset. So the difference between the network reset and then the edge reboot or the edge reset is that basically this network reset, it only resets the private LTE part. So when you do network reset, the edge stays online, the data center connectivity is not impacted, but the private LTE, the VNFs, they are being resetted. Later also in the software management part, I will talk about it, that this step might be needed in case there is, for example, some update in the private LTE core components, private LTE software, and also it can be needed also because of some configuration changes. Here it's being mentioned that the main configuration changes where it's needed is when, for example, a new APN is added, when some of the existing APN, like for example the IP configurations related to an APN change, and also when the local breakout changes related to a network. In order to take these new settings into use, you always need to do a network reset. And then the main thing is that it causes basically downtime as long as the VNFs, as long as the private LTE network components are not coming up again, your private LTE network will not work. And as mentioned, it is needed, and it might be needed to update the Packet Core software from time to time. So this network reset can be executed by clicking here on this network view, selecting the actual network that you would like to reset, and then by clicking on this reset button. Once you click it, you need to reactivate, so to say, the network and go through this finalize and apply states. You will see it once you execute this operation. It's just to highlight that there will be further actions to be done on the customer UI in order to bring the network back online. The next topic, or the next, let's say, entities in the network are the SIM cards. So once you click on this SIM card view, you are able to see all SIM cards that are associated and added under that given account. You can see for each and every SIM card to which network they are being provisioned, they are being assigned to, and you can also see the APN that they are using. In case they are using static IP, then you see also the IP settings, you see the QoS that is associated to the SIM card, and whether they are, and their status is whether they are active or not. The main operations related to the SIM cards is basically to add them to a network, to remove it from a network, and certain status information. So let's start with this provisioning. So here again you can see the view with all the SIM cards. Like for example, this worker one SIM card is not yet associated to any network. So when you click basically provision, this provision button, then it will be provision to the selected network. Similarly, when a SIM card is being already used by a given network, then you can deprovision it from that network and make it available, provision it back to another network. It's also possible to provision a SIM card to several networks. So when you click on a SIM card that is not yet provisioned, you have this network view, and under this network view you see all of the networks that are again under that same account. And for example, if you want to use the SIM card in several of your networks, then it's possible to associate, to provision the SIM card to several networks. And this is also the place where you are easily able to select to which network you want to provision your SIM card to, and then by applying it, the SIM card will be provisioned to one or several of the selected networks. And the last operation related to the SIM cards is called this bulk operation. So this is being used when the customer has a quite high number of SIM cards. I think as per today, 2021, the biggest number that we can manage this way is 5,000. So this bulk operation is being used to add a high number of SIM cards to the system by filling up the SIM card details in a CSV file. So and that CSV file has a predefined structure, which is obviously agreed before doing this operation. And if all the SIM cards details are added into the CSV file, then basically with this one click, it's possible to add those SIM cards to a selected network. This is being done on this network view, so not on the SIM view, but on the network view. And then when you go here under the SIMs, which again lists all the SIM cards related to that given network, you have this import function. So again, this is used when you have a very high number of SIM cards that you need to import and provisioned to a given network. So it avoids you basically doing the clicking and adding the SIM cards one by one, what you had to do on the previous, or what I was showing on the previous screens. On this video, you can see that, let's say, the detailed view that you have once you click on a given SIM card. So once you click on a given SIM card and you scroll down, you have this throughput information. It means that for each and every SIM card, which is a UE, which is like your end device, you are able to see the exact current throughput, and you are also able to see some historical data. So what the cursor was showing on this scale is that a couple of days historical data is visible in terms of the uplink and downlink generated and used by this device. The next big topic would be the radios, the access points. So the access point information is again accessible under this discovery and access point view, and similar to SIM cards, similar to the edge clouds and to the networks, you get like a kind of inventory. You get a list of access points that you have under that network. For each and every access points, you have basic information like which kind of technology network they belong to, the ID of the access points, certain status information, and also the model. So about the status information, three things are differentiated. One is whether the GPS sync status, whether the GPS is in sync or not, whether the edge connection, so the connection between the edge cloud itself or the edge hardware itself and the radio is up or not, and this connection this connection is needed basically to manage the access point. That's why it's needed, and whether the given access point is on air or not. That's what this status is showing. And through other views and then through the specific management steps of the access points, you will be able to see that what operations the customer can do, including locking, unlocking, rebooting the access point, and then what kind of parameters and status informations are still visible related to the access points. Once you select a given radio, then under this action view, you are able to either lock or unlock that whole radio. So by this toggle button, you can, when it's enabled, then you can lock it. When it's basically locked, then you can unlock it with this same functionality. And of course, you also have the reboot capability remotely of the whole radio, of the whole access point. Going further in this side menu, you have this cell level information. So once you click on an access point, this gives you information about the cells that are commissioned under that given radio. Again, the cell status, and you can also lock specific cells under that given radio if you want to manage the cells individually on cell level and not do these operations on the radio itself. As for the parameters and as for the basically the informations that you can see about the access points, so you have here the access point ID, the IP address, and then this basic sync source information. These are relevant and valid for the radio itself. And for the cell, so again in this cell level view, you are able to get cell level information, which are mainly the cell ID and then the frequency. This view is changing if you have a TDD or FDD. So for FDD based systems, you have the uplink and then the downlink frequency also here, and it also changes in case CBRS is being used in the United States, where you have all the CBRS specific information also here under each and every cell. The the last view in this menu are about the alarms. So this customer portal, it shows you the active alarms related to a given access point. When you click on it, or like when you hover over the alarm, then you can see the ID, you can already see the name, the severity, and so on. So these are all the active alarms related to a given access point. And then the other operation or like troubleshooting capabilities to collect signaling traces. So in general, signaling traces can provide options to check signaling, and then so control plane and then user plane messages related to, for example, a given call or a given UE, and it can help you in troubleshooting, for example, connection issues. So these signaling traces are also being collected by the NDOC system, and triggering those traces, it's being managed on this customer UI. I will show it on the next slides that customer or operation engineer is able to trigger the collection of these traces, download these traces, and the analysis of the downloaded traces is being done in an offline manner, is being done by an external tool, which is always let's say a separate discussion and a separate topic, how to get access to that tool. But on the high level, the signaling traces can be downloaded from the end systems. And this is this cell trace view. So the third option in this view, where related to a given access point, you can first of all enable the cell trace collection with this toggle button. And once you enable the cell trace collection, you have a list of available cell traces. You have a list of available traces that you already collected, and you can download those ones on your laptop. This is the kind of the step-by-step view and the step-by-step guide that how it's being done. So once you click it here, then the cell trace is off, so it's not being collected. The cell trace operation is successful, so it was enabled, and then it's ready to download, and then you are able to download these cell traces on your laptop. And then the last topic I'm going to talk about under this discovery view are the applications. So these applications are, or the customer portal provides you management capabilities for those applications that has been purchased for the given network. Here in this view, you only see the purchased applications. You don't see a complete list of all available applications. So it's not like a complete marketplace in that sense that we have the full list and then you just select, but only those applications that has been purchased and for which the license exists under the given account, only those are available here. When you click on a given application, then kind of similarly to how is it to other parts of the NDOC system, you can see that on which network that application is running. So here, for example, you have 3 networks, and you can see that it's only running in the middle network. What is the software version of that application? Status information. So for example, in case it's like failing for some reason, you can also see it here. And these 3 dots gives you basic options to retrieve additional data related to the application. So for example, this app reported data and app configuration parameters, it can provide you information about the exact parameters which were used to provision the specific applications, and the app reported data, that means those set of parameters that the given application would like to report back to the user. For example, the certain IP parameters or certain dynamically allocated parameters are being visible under this app reported data, and customer can deploy and undeploy the applications through this view as well. So that was the first part about the troubleshooting capabilities, and now I'm going to talk in general about how the NDOC software management is being carried out, how we update, manage the DC, edge, and then the radio softwares in our networks. Let me start with describing more or less the R&D cycles and then the R&D development releases. So we have these 6 months releases, which are all named by cities. After Geneva, we have now the Helsinki release, and the R&D work is being organized in these 6 months releases. The main points is that whenever any feature is ready, the features are being constantly and continuously pushed into the live networks. So we do this continuous integration of the ready features continuously, meaning that, for example, one NDoc release doesn't mean that the full content is available at the end of the release in one go, but we keep pushing regularly, weekly, bi-weekly, the new content and then the new software to the live network and to the data center. So during each 6 months window, all these new features are gradually and seamlessly deployed to the regional data centers and to the edge clouds. About how the data center cloud operations and then the software maintenance service in general works. So the NDoc solution and NDoc system, they are offered with a time-based subscription. So usually you get like a monthly, or like every time you get a monthly subscription, and that monthly subscription, it contains the operations of those NDoc networks. So these operations and these management activities are being carried out by the NDoc operations team, who are sitting in several locations all around the world, and their responsibility is to operate and maintain these customer networks during the business hours, or if the SLA states otherwise, then higher level of SLAs and higher level of availabilities can also be provided. So this operation team, they are monitoring the NDoc networks, the hardwares, and the private LTE network from the data centers to always ensure that they are always up to date and they always meet the customer SLAs. For every software update, updating the edge, updating the radios, all these software updates are being managed from the data center. So that's why the data center connection towards the edge clouds is always required, and these software updates, automatic software updates, are always orchestrated from the data centers. Through these continuous software updates and releasing features and releasing also fixes, obviously continuously, we ensure that the LTE network and then the NDoc edge software stack is always up to date. We always keep the fleet on the same software level. Yes, and with that we ensure that all edge clouds are on the same, or at least n-1 software level, and they all get the latest improved features. Important thing to highlight is this maintenance window. So every customer is expected to agree with NDoc operations team on a maintenance window every month, where these software updates can be scheduled, and when these software updates on the NDoc edge cloud can be pushed. Operation team informs through release notes that what is the content of the new software release, when exactly is it coming. So this information sharing is a quite important communication part towards the customer. Of course, if there are like some very important fixes or bugs, then they can be always pushed kind of outside of this regular schedule, so they can be scheduled separately. And each and every of these cases, of course, customer will be informed if there is any urgent fix that needs to be pushed, and what's the implication of that. You can find here this info center, so the customer documentation link to this software management process, so you can also check that further. About the specific software updates and the specific software process for the edge and then the access points. That's what this next slide is about. So the edge software updates, they are being done mostly monthly, and in general they are not impacting the private LTE network, meaning that usually the updates are only related to the edge software stack, but not, for example, related to the private LTE VNFs. And during this update, the edge software stack, the microservices are being updated, new versions are being pushed on the live networks, and parallelly to this, the DC side is also updated. We are also able to update the DC side separately from the edges. Sometimes these DC and edge updates they go together. Sometimes they follow a slightly different schedule, but both the DC and the edge, they are updated regularly. Then the point I have been mentioning about the network reset is that in certain cases we need to update the packet core. We need to update the VNFs, and in that case, the software activation requires this network reset operation, which is around this 10 minutes downtime. So for this, there are two options. So either the customers can do this whenever they want and whenever they see the best time for their private LTE network, so they can do it on this customer portal as I've been showing it, or the operation team can also obviously execute this network reset and then this operation during the agreed maintenance window. The operation team again informs the customer in advance that what are the changes in the release, so what are the changes coming in the release, and also notification if we need to reset the private LTE network. In case of critical software fixes, we can push them anytime during an agreed window and agreed schedule with the customer. So as for the access points, it's slightly different because the access point, so the eNodeB and then the radio software upgrades, they are usually being done twice a year. So radios are running 6 months on one validated software version, and there is always a separate plan and a separate schedule how those radios are being updated, when can obviously those radios brought down for software management and software update purposes. But obviously there is the possibility that those radios are being updated one by one, not impacting the radio coverage and then the private LTE coverage. So in summary, the advantages of this software management and software update process is that the customer always receives the latest software updates, software fixes, and then new features through these regular pushes. They can control themselves when the upgrade is activated through this network reset functionality. As long as the network reset is not executed, for example, the VNFs are not moving to the new versions, so they can control when they activate the new version. NDoc is trying to keep all edges on the same software level, on the same software stack, providing the same features and fixes to everybody. And as for the access points, as I have been mentioning, so it's a separate agreement, but access point upgrades can always be done one by one, so that the whole network is not impacted during this software upgrade process, and this is being done usually twice a year. That was it about this troubleshooting and then software management process. Thank you very much for your attention.